Hey guys, it's Mike Demaio. I'm going to be giving a quick VBA intro so you can maybe learn some syntax. And we're going to have to get started by installing the developer tab here. It's pretty easy. You just say File, then you go to Options, Customize Ribbon, and then make sure this developer tab is checked off. Once you press OK, it's going to show up right here, and we are ready to get started. So you click this Visual Basic button, and under the VBA project, double-click Sheet 1. So our first step is going to be to create a subroutine. So you type in sub name, what you want the subroutine to be. In this case, we're going to use Hokies, and then it's going to automatically generate the end of the subroutine. Next, we have to start to dimension variables. So you'll say dim x as integer. So what I hear was I said I'm about to declare a variable, I named my variable, and then I said what type of variable it is. So there's a bunch of different types. We can say dim y as double, and we can say dim z as long. These are examples of 3 numeric variables. There's also string, so a as string. And then there is a variant. And so the string is good for words, sentences, characters. Variant is a very open variable. It's not going to restrict you to be a string, long, double, or integer. It can adapt to what you put into it. And there's a bunch of other variables. So you can say dim, c as time. Date. So there's a bunch of different variables you can use, and you don't have to declare variables. VBA is smart enough to know that if I say d is equal to 1, that now d is an integer. So it kind of did the declaring of the variable by itself, but it's good practice to declare those variables because later on, as your code grows, it's going to be very hard to follow along if you haven't declared them at the top. So we're going to move on to for loops now. Actually, we're going to talk about another type of variable, which would be a vector. So you say dim example array. So it's very similar to before. You say you're about to declare a variable, you give the name, but now you put a parentheses there, and you put the value of the number of slots you want for variables. So I'm going to say 5, and then I'm going to create this variable as an integer. So what I just did here was I declared a vector, a 1 by 6 vector, and I said all those slots are integers. There's 6. This has created 6, a 1 by 6 matrix because it goes from index 0, index 1, 2, 3, 4, and 5. And so now we can use this as a good transition to a for loop. And so a for loop is good when you know you want to do 5 iterations. So it's a user-defined stop. And so for this example, I say for I to 5, and then at the bottom, next I. And this is because I created my example array that has 6 slots, but I'm only going to care about indexes 1 through 5. So I'll say example array I equal to I times I. So what this is saying is that each iteration go to that index. So example array I, on the first iteration, that'll be example array index 1, and then it's equal to 1 times 1. Example array 2 is equal to 2 times 2. So we're going to see how this is going to execute now when I use the step into function, which is really good for debugging your code if you're not sure how it's going to work. The same thing with add watch. So I'm going to add a watch on the example array variable, so that way I can see the values as we run the code. I'll delete these for now. And so we're going to step into this code. So now you can see example array has been defined, and as we step into it, is equal to 1, 2 times 2, 4, 3 times 3, 9. And that's how the for loop goes. So that's good when you have a set number of iterations you want to run through. Another type of loop would be the while loop. So you say while I is less than or equal to 5. And then you say WEnd, and that ends the loop. So while I is less than or equal to 5, this loop will keep running. So if I say I equal to 5, we can see how this is we'll see how this runs when we step into it. So again, we'll use the step into function to debug how this is going to work. I is equal to 5. Since it's saying while I is less than 5, enter this loop, it's going to skip right over the loop and the code's not going to execute. So now we'll say I equal to 1, and we'll declare the variable like we actually talked about earlier. Dim I is integer. So now we'll show how the code works. I is equal to I plus 1. And so it's going to enter the loop, increase by 1 for each iteration, and once I is equal to 5, the loop will end. So we're going to step into it again. 3, 4, 5, and now it should exit the loop, and it does. So that's another example of the while loop. This is good when you don't have a user-defined stop value or iteration value, but instead you know you want to stop when maybe a certain value has been attained. So once you cross a certain threshold or something like that, you should exit the loop. Now I showed you an instance where if I is equal to 5, it's not, this loop would cut off immediately, but there could be a case where you don't want that to happen, and that's why the do while loop exists. So you would say do down here loop while I is less than 5. So a do while loop is great because you know I is equal to 5, this is going to stop. It's not even going to enter the while loop. But if you want it to always enter the loop at least once, you should do a do while. Therefore it'll run at least 1 iteration before it stops. So we'll take a look at that right now. I guess we'll add a watch to I so we can see the value of that. So I is equal to 5. If it was a while loop, it would never enter the loop, but in this case it's going to enter the loop, run once, and then stop. So I is equal to 5, do, it adds 1 to it, I is greater than 5, and therefore the subroutine ends. So that's another example of you have a stopping criteria, but you always want the loop to execute at least once. And so now we're going to move on to input box, message box, and if statements. So this will be good. The VBA can also take user input. So this is good if you're creating something for a client or your boss and maybe they want to input a value. It's going to run a bunch of code on it and then output something else. So I'm going to declare x as an integer. Then I'm going to say x is equal to input box. And then the prompt like, what is the value of x? And so when I run this code, it's going to pop up and say, what do you want x to be? And then I'll say if x is greater than 1 and less, and x is less than 3. We should say less than or equal to. Then this is going to be a block. This is a block if example. We'll also do else if x sorry, I'm just trying to get the structure of it. X greater than 3 and X less than or equal to 5 then, and then else, and then end if. So this is going to be the structure. And we'll say X is equal to X times X. X is equal to X minus 1, and then else X is equal to X times X minus 1. And then at the end, we're going to have an MSG box, which is an output, and it'll show us what the value is. So basically what's happening here is I'm declaring a variable x as an integer. I'm going to ask the user what he wants the value of x to be. If x is greater than or equal to 1 and less than or equal to 3, it's going to perform this function. If it's greater than 3 and less than or equal to 5, it's going to perform this function. And anything else, it's going to perform this function. So now we're going to go ahead and run it. So what is the value of x? I want to say 2, so it should spit out the value of 4, and it does. That's because since it's 2, it entered this loop, did 2 times 2, and gave a value of 4, and then ended it. And that's what the purpose of the message box was. So there's also something we can do called a user form. That's great because you can essentially turn your code into one big user face for whoever's going to be the end user of what you're using VBA for. For the purpose of this video, I don't think we should cover it, but it's something maybe you should Google if you're interested. And there's 2 more things I think we should cover. One of them would be using the record function, and then also there is, so the subroutine is maybe where you run most of your code, and there's something called a function. And so you can say function, name your function, and so we'll say Hokies 2 parentheses x as integer comma y as integer and then as integer. So what I've done here is I created a function, named it Hokies2. I said it takes an input of x as an integer and an input is y as an integer, and then I have this whole function equal to an integer. Now this is great if you have a very repetitive task. And generally it's going to be more complex. This is going to be a simpler example of a function. But if you're going to be doing a very intensive repetitive task over and over, it's best to do one function at the bottom, call that function 10 times, then write that long code 10 times in your main subroutine. So what we're going to do is we're going to call that function Hokies2, and it knows it takes an x as an integer, y as an integer, and so we'll say z comma y because that's our input. And we're going to say MSG box that value, and we have to give x and y a value. We'll say x is equal to 3, y is equal to 2, and then we say Hokies 2 is equal to x times y. Okay, so the way this works is I dimensioned z, I dimensioned y, I give them both values, and then I call the function here, Hokies2 z times y. So I have to rename that. Z times y. And so that comes in, that calls the function Hokies, and it says whatever is in this slot right here becomes now the variable z. And it should be an integer, and same thing here, y to y. as integer. It comes in, multiplies x times y, and then returns this value's Hokies 2 into here. So when we run this, it should output the value 4. We'll take a look as we run it. And it might be useful to add a watch. Add a watch and watch this thing run. So I'm going to step into here. And it goes down, calls the function, does x times y, end function, return, message box equal to 6, and the subroutine ends. So that's an example of a function. That's great when you have a really repetitive task that's going to be a little more involved than maybe multiplication. Because in this instance, we could do that 10 times. But if we had to do 10 lines of code per function, it'd be good to write a function for that and call it 10 times rather than write 100 lines of code. And so I think with that, it's covered a lot of things on the front side of VBA. The last thing I think we should do now is maybe show you how the record function works a little bit. And maybe I can do a quick example of how it could be useful. So let's try and get these screens to be parallel. Just give me a second. So whenever there's something you don't know how to do, like if to transpose some rows to columns, it's a great idea to record the function, execute it, and then look into the VBA code to see how it was done. That's a great way to learn, and that's how I do it when there's something I don't know. So let's start. We're going to say record. Well, first, we'll put in some values. 1, 2, 3, 4. So now we're going to record. We're going to name it transpose. And so we're going to be able to see this macro actually happen live. So we highlight it, copy it, select here, and say transpose. We're going to stop recording now, but you can see this is something they're calling an Excel application here that we might not be able to know off the top of our heads. So this is great to learn this transpose function here, and you'll be able to reuse that later if you need to. So here's I'll quickly write up a good example of how we can automate using the record function. So let's say we have 1, 2, 3, 4. 1, 2, 3, 4. So let's say you have to just transpose these rows. You could do it line by line individually, or you could record, or you could turn on relative reference and then record a function. So the way this would go, you start where you want to start recording the function. You record it, name it transpose, and then click here. Transpose, and then select where you want it to go next time. Once you've done that, you can say stop, and this will be a nice repeatable macro that we can now show you how it's going to work. The code is in here, but since we turned on relative reference, we're going to be able to exploit that to quickly automate this, what was previously a very repetitive task. So we insert a button. So we're going to say it's going to use the transpose, and so click it, click it, click it. Now you can transpose very quickly. You can make this even better if you implement maybe a for loop, or you can do a dynamic array or something like that. But that's a very quick demo of how you can use the record function to automate some very repetitive tasks. We'll talk about this more maybe in a later video or in class. So thanks for watching.